Okay, so the Mathematica stuff is going to be a little more complicated to work with the files, but let me just show you how you can move the files from where they are to where you need them. So in D2L, let's try to find that tab. We'll have our assignments. Let me just turn to student view so you can think that makes my screen look more or less what yours look like. So if we go to the assignment for week 1 with Taylor polynomials, there are two files here. I put this as a PDF because the worst case, if you really can't download the file but you can access Mathematica, the worst case is you can copy and paste text out of the PDF file. So that's just a PDF version of the Mathematica notebook. But what I can do, I can either say download all files, or I can just download this directly to my machine. So I'm going to say save link as. I'll put it in my download folder. And so I have the .nb file here in my download folder. So the first thing I'd want to do is name it so that it goes with me. So I want to rename it. And this is important on my end, because if you do have to submit it some other way, then everybody calling their file the same thing will be confusing. But if it all works well with submitting through D2L, then it doesn't matter that much. But go ahead and change it anyway. Better safe than sorry. So that then folder is in my download folder. So now if I go to my Mathematica, click on the file link, it'll show you all your files. If it doesn't show you the right ones, you want home. There's another number of options there. So that's all the files that I have in my Mathematica WolframCloud folder, so that I can just drag this guy up to the cloud files and let go. There he is right there. Then double clicking on him in the cloud folder. Opens them up like that. Then I can just work like a normal person in this file. It's good to put your name in here somewhere. Again, just in case things get confused. And then you'll complete the tasks down here. So for the tasks, I would, remember you can make some separators using format. You'll get some formatting options over here. So we can say problem 1. And the problem's going to start by defining the next function that we're using. So for problem number 1, we're defining f of x cosine x. Don't forget also, when you launch Mathematica, it doesn't know what anything is. So you'll have to hit your enter. For my computer, it's shift return to execute those lines to tell it. It doesn't save the defined variable states. It just shows you the picture of what you had before. So so this now will do what it's supposed to do. F of 0 should be 1. F prime of 0. Technically, that's the derivative would be negative sign, and negative sign of 0 is 0. So that's what I'm getting. So so then I can build my polynomial, and you can't just copy and paste. I mean, this would be the third degree polynomial right here. So I copy that and paste it down here, then p of x is now the third degree polynomial. You can see in this problem, I want the fourth degree polynomial, so you'd have to add one more term to that. But that would be how we do that. And then like before, I would want to grab this command to show the graph, and so that should show the graph of f and p together on the same screen. I do want you to fiddle with the scale, because it may be that if you look too narrowly around the center, the two graphs will look exactly the same. So it'll look like you've only plotted one thing. So I want you to spread out the window so that you can see the part where the graphs are the same, That's going to give us a visualization of what we call the interval of convergence, and but also have it spread out wide enough so you can see where the two graphs start to separate as well. So the point where the graphs are similar is really going to be the takeaway for what we're going to talk about next week. So so that's it. So there's really 3 lines in this for each problem. There's defining the function, there's defining the appropriate polynomial, and you have to look at what degree you want, and then there's plotting them and fiddling with the ranges. You don't have to evaluate these things in between. I only did that to make sure that I felt like everything was defined correctly. Once you're done with it, you can come here to, you can either download the .nb file and submit that to me. That's fine. My preference would be that you go to this option and say print to PDF, which will give you a nice looking version of it. And then, at least on my computer, I have an icon up here for the printer. So if I click that printer, then under the destination, one of the options is save as PDF. So if I do those steps, and I'll just let it go to my download folder again. If I do those steps, then my final version ends up being in my downloads folder. It's a PDF file. So let's take a quick look. We can see that my name is in there. My fiddling with cosine is in there. It's now an up-to-date version of my work. And so I can go back to the D2L link for the submission, which would be here for submitting an assignment. And I can just drop my PDF file right there, upload, and I'm done. So it's got extra steps in it than what I originally intended. But it really is just a matter of moving the file from D2L into WolframCloud and then getting something back out to put back into D2L. The actual mathematical work should be the same.